Download this code from codegive.com, link in the description below. Bypassing API rate limits with openrouter proxy server for RAG applications. API rate limits are a common constraint when building applications that rely on external services, such as large language models, LLMs, like OpenAI's GPT models. Hitting these limits can significantly impact user experience, causing delays or outright failures. One effective strategy to mitigate this is by utilizing a proxy server like openrouter. What is openrouter? Openrouter is a service that allows you to access multiple LLMs through a single API endpoint. It's essentially a proxy layer that offers several advantages. Smart routing. Openrouter can route your requests to different LLM providers based on availability, performance, and cost. This distributes the load, reducing the chance of hitting rate limits for a single provider. Fallback mechanisms. If one LLM provider is experiencing downtime or rate limiting issues, openrouter can automatically switch to another provider, ensuring continuous service. Simplified integration. You interact with a single openrouter API, simplifying the code compared to managing multiple direct integrations with each LLM provider. Cost optimization. Openrouter can help you find the most cost-effective LLM for your specific needs, reducing your overall expenses. Rate limit management. Openrouter manages the rate limits of the underlying providers. Using openrouter provides a greater rate limit than using the APIs directly. Why use openrouter for RAG? Retrieval Augmented Generation, RAG, applications, which combine external knowledge with LLMs, often involve numerous API calls. 1. Embedding generation. Converting your knowledge base into vector embeddings using models like text embedding ADA 002. This can involve processing a large number of text chunks, leading to frequent API requests. 2. Semantic search. Querying the vector database to find relevant passages based on user input. This can involve multiple embedding calculations and database queries. 3. LLM generation. Feeding the retrieved context to the LLM to generate the final response. Depending on the complexity of the response, this might require multiple API calls to handle token limits. The cumulative API calls in a RAG system make it especially vulnerable to rate limits. Openrouter provides a robust solution for managing these limits and ensuring the smooth operation of your application. Tutorial: Integrating openrouter with a RAG application, Python example. This tutorial outlines how to integrate openrouter into a basic RAG application built with Python, LangChain, and a vector database, ChromaDB. It will cover the following steps. 1. Setting up your environment. Install necessary libraries. 2. Configuring openrouter. Obtain an API key from openrouter. 3. Loading and embedding data. Prepare your knowledge base and generate vector embeddings. 4. Building the RAG pipeline. Integrate openrouter's LLM into the LangChain RAG pipeline. 5. Handling potential rate limits. Implementing retry mechanisms and error handling. 6. Testing and monitoring. Verify that your application is working correctly and monitor its performance. 1. Setting up your environment. LangChain, a framework for building LLM-powered applications. ChromaDB, an in-memory vector database for storing embeddings. Alternatively, you can use FAIS or another suitable vector database. OpenAI, the OpenAI Python library. Used to calculate embeddings. Tick token, a fast BPE tokenizer for use with OpenAI's models. FAIS CPU, FAIS, Facebook AI Similarity Search, a library for efficient similarity search and clustering of dense vectors. If you're using FAIS Asterisk openrouter, the openrouter Python library. 2. Configuring openrouter. Asterisk sign up for an openrouter account. Asterisk visit https://openrouter.ai/ https://openrouter.ai, and create an account. Asterisk obtain your API key. Asterisk navigate to the API keys section in your openrouter dashboard and copy your API key. Asterisk enable the models. Asterisk you will also need to enable the models you intend to use. For example, enable OpenAI's GPT 3.5 Turbo model. This is done in the dashboard in the Models section. 3. Loading and embedding data. This section demonstrates how to load data, chunk it into smaller pieces, and generate embeddings using OpenAI's text embedding ADA002 model through openrouter. Asterisk openrouter_API_key asterisk set this environment variable to your openrouter API key. This is crucial for authentication. Asterisk text loader asterisk loads the data from a text file. You can replace this with other loaders from langchain.document_loaders based on your data source, example PDF loader, web-based loader. Asterisk character text splitter asterisk splits the loaded documents into smaller chunks to improve the quality of embeddings and prevent token limit issues. Asterisk OpenAI embeddings asterisk initializes the OpenAI embeddings class, specifying the embedding model, text embedding ADA002, and API base. Asterisk chroma.from_documents asterisk creates a ChromaDB vector store from the text chunks and their corresponding embeddings. The persist_directory parameter specifies where to save the database on disk. Asterisk db.persist, asterisk saves the ChromaDB vector store to disk. 4. Building the RAG pipeline. This section demonstrates how to integrate an LLM, example GPT 3.5 Turbo, accessible through openrouter into a LangChain RAG pipeline. Asterisk OpenAI, LangChain initializes the OpenAI LLM integration through openrouter. Asterisk model_name, specifies the LLM model to use. Important, make sure the model is enabled on your openrouter dashboard. Asterisk temperature, controls the randomness of the generated text. Lower values, example 0.0, produce more deterministic outputs. Asterisk API_key, your OpenAI API key. Asterisk API_base, the openrouter API base URL. Asterisk max_tokens, limits the maximum number of tokens in the generated response. Asterisk chroma, persist_directory, embedding_function, asterisk loads the ChromaDB vector store from disk. Asterisk db.as_retriever, asterisk creates a retriever object from the vector store, which is responsible for retrieving relevant chunks of text based on a query. The search_quarks parameter allows you to customize the search behavior, example specify the number of chunks to retrieve. Asterisk retrieval QA.from_chain_type, asterisk creates a retrieval QA chain, which combines the LLM and the retriever to answer questions based on the retrieved context. Asterisk chain_type, specifies how the retrieved context is combined with the query before being passed to the LLM. Stuff is the simplest chain type, where all retrieved documents are stuffed into the context. Other options include map_reduce, refine, and map_rerank, which offer different trade-offs between performance and complexity. Asterisk return_source_documents, if set to true, the chain returns the source documents used to generate the answer, which can be helpful for debugging and verifying the results. 5. Handling potential rate limits. While openrouter helps manage rate limits, it's still crucial to implement your own retry mechanisms and error handling to ensure robustness. The most common rate limit error is 429. Query with retry, this function encapsulates the retry logic. openai.error.rate limit error catches the specific rate limit error exception raised by the OpenAI API. Exponential backoff implements an exponential backoff strategy, where the delay between retries increases exponentially. This helps to avoid overwhelming the API with repeated requests. Logging uses the logging module to record warnings and errors, providing valuable information for debugging and monitoring. 6. Testing and monitoring. Test thoroughly. Test your RAG application with a variety of queries to ensure it's functioning correctly. Monitor API usage. Keep track of your API usage through the openrouter dashboard to identify potential bottlenecks and optimize your application. Adjust rate limit parameters. If you consistently encounter rate limits, consider adjusting the chunk size, embedding model, or LLM to reduce the number of API calls. Monitor response times. Implement monitoring to track the response times of your API requests. This can help identify performance issues and potential rate limiting problems. Advanced considerations. Caching. Implement caching mechanisms to store frequently accessed data and reduce the number of API calls. You can cache embeddings, LLM responses, or retrieved context. Queuing. Use a message queue, example RabbitMQ, Redis queue, to handle API requests asynchronously. This can help to smooth out traffic spikes and prevent rate limits from being exceeded. Dynamic model selection. Implement logic to dynamically select the best LLM based on factors such as cost, availability, and performance. OpenRouter's smart routing capabilities can be used to achieve this. Fine-tuning. Fine-tune a smaller LLM on your specific data to reduce the cost and latency of API calls. Request batching. If the API supports it, batch multiple requests into a single API call to reduce the overhead of network communication. Benefits of using OpenRouter. Reduced rate limit issues. By distributing requests across multiple LLM providers, OpenRouter reduces the risk of hitting rate limits for a single provider. Improved availability. OpenRouter's fallback mechanisms ensure that your application remains available even if one LLM provider experiences downtime. Simplified management. You only need to manage a single API key and endpoint, simplifying your code and infrastructure. Cost optimization. OpenRouter can help you find the most cost-effective LLM for your specific needs, reducing your overall expenses. Future-proofing. OpenRouter allows you to easily switch between different LLM providers as new models and technologies become available. Conclusion. OpenRouter is a valuable tool for building robust and scalable RAG applications that rely on LLMs. By providing a proxy layer that manages rate limits, ensures availability, and simplifies integration, OpenRouter can significantly improve the performance and reliability of your application. Remember to complement OpenRouter's capabilities with your own error handling, retry logic, and monitoring to create a truly resilient and scalable system. Always test thoroughly and monitor your API usage to optimize your application for cost and performance.